Welcome to Coding with Ashok, and today I am very excited for a new ML project where I will predict the Titanic survivor. So before starting any ML project, we always need to think whether this is a regression or classification problem. So we are predicting the survivor. So obviously this is a classification problem. So let's begin with this amazing project. Okay, so I have started this project in the notebook and I have named it Titanic survivor prediction through machine learning algorithm. Okay, so we need to import the libraries. I'm importing. We always need to import the pandas. Import numpy mp matplotlib matplotlib and we are also importing the Seaborn. Basically Seaborn are okay. So this string symbol tells us that it's still under the execution compilation. So okay, before now we need to read our CSV file. For this I am just naming a data frame df and pd dot read underscore CSV, and data name is like Titanic dot CSV. Okay, let's run this. Okay, we have successfully run this. So before going on the further, we just need to look on the Titanic dot CSV. Actually CSV file is a comma separated files which allow data to saved in a tabular form. So you can see here each and every thing in this data is separated with the comma. You can see the row, column, everything column. Okay, and we save all this. Okay, it's my PC is a little slow, and we are kind of editor. Okay, so we have saved this Titanic.csv in our data frame called df. So data frame is a tabular or two-dimensional array like a structure in which each column contains values of one variable and each row contains one set of values from each column. The column name shouldn't be empty. Okay, so let's see what's the name of our column. Okay, here. Okay, let's explore this variable, the column names. Passenger ID. Okay, the ID of the passenger. Survived means the people who have survived. 0 means they haven't survived. 1 means they have survived. P class means passenger class. 3, 2, 1. Okay, 3 means third class, 1 means first class, and there must be the 2 that means the second class. These are the name, this is the sex, this is the age. Civ SP means siblings and spouse. Parts means parents and children traveling along with the workers. Or ticket, this is the price of fare. Cabin, which cabin. Embark means from where they belong. So let's save. Let's check its shape. Its shape is 891, 12. 891 means the number of rows and 12 is number of the column. Okay, and let's describe this column. So let's describe this data frame. Okay, this is the passenger ID where you can see its minimum value is 1, maximum is 2, 3 something. We don't actually need this passenger ID. Okay, this is the survived. Okay, survived. Okay, it has 891 okay, its count is 891. Everyone count is 891 except this age. So we can predict that in age column there are lot of missing datas, and you can see here the mean is 0.42 000 something. So this means a child haven't born even, so they are 4 months in their mother womb. So you can see the siblings parts. Okay, we have to take a look. Now let's check that. Let's check its data type. Okay, so you can see the passenger ID is the integer, survived is the integer, P class is integer, but the name is the object type. Sex is also the object type. This is the sex is the categorical variable. Age is also is a float. SIB. Okay. Here is the cabin is the object. Ticket is also object, and embarked is also object. Now we will be doing the EDA. That means exploratory data analysis, and we will be doing the EDA through the data visualization. So we have imported two libraries that are called the Matplotlib and the Seaborn. So we will be using this for the data visualization. Okay, so let's visualize the data through histogram. Okay, let me write EDA from is exploratory data analysis. So we are doing through visualization. Okay, it will be heading. Okay, so let's plot the histogram. We are grouping the GROU group. We are grouping the histogram by the survived people. And histogram figure size we have taken 9 by 9. It's saying that there is the error. What is that error? Must be set. There is the comma. Okay, that's by means comma. Okay, so it's under the process, working process. Okay, so we can see here the age group. The people, the likely to be the most people who is around what is data, maybe 18 or 17. Okay, from 17 to the around the 40, they are the people who have died more, and the person whose fear is high, they are likely to die less. Okay, it's working. Okay, see here, and this is the parts. The people who have children, they are likely to die more. This passenger ID with the okay, the class. The person traveling the first class are likely to die less, but the third class people have died more than the first and the second class. Obviously money matters, but this is spouse. The people who have more number of siblings and people who have the spouse are likely to die more. Okay, this is by the age. Okay, fear, passenger ID. Okay, you can take a nice look at this. So after doing this, we will be counting the survivor. COUNT. Okay, we are using data of this our df set. Yes, let's explain this. Okay, survived. Okay, you can see 0 means the people who have died and 1 means the people who survived the Titanic disaster. So it seems that there are more number of people who have died in the Titanic as compared to the people who have survived. Okay, so let's categorize this by the sex ratio. Okay, so then dot we have select by mean. Okay, we have taken the mean of the people who have survived here. Okay, sex survived means the female are likely to survive, like 74% of the female have survived, but only the 18% of the male have survived, who are likely to be the first class, who are likely to traveling in the first class. Okay, now let's do the bar plot for this. We will be using the Seaborn. X-axis be the sex and y-axis let it be the survivor. We have copied, so let's paste. Using the data equals to df. Okay, it's plotting. So you can see the most of the women have survived this disaster, but very few number of people have. Okay, let's take a clear look by count plot. See, if you can see clearly here, and the male 0 means the people who have died. Okay, 0. So you can see here the men are likely to die more than the women, and you can see the women have survived more than the men. Okay, but just visualizing data. Now let's do the pie plot. Pie plot according to the passenger classes. This okay, there's P class means passenger class. Okay, so is there any error? No. So we need to plot this, means dot plot so let's plot this. Okay, you can see here these are the P. Okay, you can see this one, this is the first class person, and this is the male. So this is the male and this is the female. So the male this is the first class male are like, okay, they survived, but their survivor are less than the women, because the first class women have survived. Maybe this is maybe around 80 something, I don't know. Yeah, this is the women has survived most, and this is the second class women has survived more, and even the second class male has survived more than the third class. You can see the third class, their rate is so low. Okay, even the first class you can see here. Okay, the first class male survivor is less than the third class female. So most of the females survived, and though that's the reason Jack died in the Titanic movie. That's a bad joke. Okay, we are doing the same thing in the bar plot. Okay, P class, and see how many, according to the class, how many of them have died. This, okay. Okay, df equals to overlapping data. Let's, okay, you can see it, the first class are likely to survive more than the second class and the third class. Obviously the money matters. Okay, so we will classify. Okay, we can take a nice look in the count plot. Okay, actually it's not giving the accurate result. Okay, it's giving the accurate, but it's it become a little bit complicated to understand this. Normally take the given that first class person have died, so the first class people have survived more than the second and the third. So we are doing the count plot where we will be comparing this set. So with the P class, and we are taking the data. Okay, dear, see here. Okay, so we have compared here. So this is the 0 means the people who have died. This is the 1 means people who have survived. So you can take a nice look. Okay, the third class people have died more than anyone. So yeah, the third class people have died more than anyone, and you can see here third class people have survived less. So you can you can analyze yourself. Okay, or let's classify. Okay, let's visualize in the scatter plot for the, okay, actually I forgot the heading, Jupyter. Okay, so we forget for the price, fair price. Okay, that's an important features. Okay, so we are scatter plotting with the class. Let's see it. By here color, we can take any color we like, so I'm taking red color, and we are label. What can we label this? We can label this the price of each class, maybe fear of each class. Okay, fear of classes, I think the fear of classes, or we can tell passenger pay something. Okay, your wish. We are giving this name as y, means the y axis. We are plotting this as P class, CLASS class, and x axis as x level. Do we need to give? We have, yeah, we can give, but I think we'll be adding one title, so that's fine. plt dot title will work as x-axis at the top. Okay, price of each class. Then we need to plot legend, legend, plt. Okay, plt dot show off Okay, let's see this. Okay, we can see here the first class people who, yeah, the first class are likely to be survive more. You can see the people who have, even there is outlier, I think, I mean that's not outlier because the people have actually paid the amount, the 500, and the first, you can see, yeah, the maybe that's the classes. First classes people have paid more than the second class people and the third class people, and the third class seem to like yeah, they have paid very less amount of money. So we'll be scatter plotting the, okay, we can yeah, let's scatter plot by the age. Okay, SCATTER. Okay, we put in the pair. Okay, by which age group paid how much amount of money. Okay, then we can put in color equals to, let me take purple. Label means we can label anything. Let this be as okay. Label means the name of name. Okay, okay, even we can remove. Okay, let it be price paid. Okay, let's just correct it. Oh, set there is invalid. Okay, we further this. Oh, set. Okay, not this one here. Okay, so we have a scatter according to the pair. So this bar, this y-axis is the pair, and this is the age. So you can see the smaller baby children, they have paid the less amount of money. Even the people who are old have paid less amount of money. Okay, but the people who are likely to attend, okay, we can classify here. Okay, so people older than maybe, I think this is 19, 18, okay, more than 18, okay, most of them have paid more, so they might be in the first class. Okay, so again let's plot okay, let's plot the passenger class with respect to the age. Okay, again we'll be doing this, the violin plot. Violin plot means actually it looks like somehow shape of a violin. Y-axis the age. So this is very easy code to understand. Okay, you can see here the age group. This is the first class. In the first class, yeah, the more, even the old people, yeah, old people are likely to be in the first class. The second class is like the young. So you can see this is the mean, or you can tell this is the median. This is the mean value. This is the first quartile. This is the second quartile. Okay, this is like the box plot. You can see its mean is yep. So from here we can tell that the first class people are more aged than the second class and the third class. Third class people's age are likely to be very less than the second class and the third class. Okay, So I think we have done enough data visualization. Okay, have we left any column? Okay, okay, we have done the sex. Okay, age. Okay, we have left this sp means sibling and spouse, and this is parent and the children. Okay, so let's do this. Let's plot this. SNS dot can't plot. This name is SIB SP. Okay, you can see the siblings and the people who don't have anyone, I mean the people who are alone are likely to survive more than the people who have one. The people who have one, the sibling and spouse, are likely to survive. Okay, they have survived around 200. People who have two, they are okay. It's in the decreasing order. The two have lesser, and 8. Okay, they seem to survive less. Even you can see the 5, up to 5, they seem to care about each other, but when it's like the 8, sibling and the spouse is like around 8, they don't care about each other, so they are likely to survive more than the 5. Okay, even we have left the parts. Okay, you can copy this code. Okay, so parts means parent and the children. Let's see the people who survive more. People having the more child and the parent with them, or the people who don't have anyone. So okay, you can see here the people who don't have anyone with them are likely to survive more than the people who have one parent or children, or two, maybe one parent, 2 children. Okay, people who have more than 3, they seem to just dead, but they care about each other. They try to go to help, so they are going for the help for other people, so they seem to die more. So lone wolf survive. Yep, lone wolf survived in the Titanic disaster, not in the Games of Thrones. Okay, let's get one more time the shape. See its shape. Okay, it's like 891 by 12. Okay, now now we'll be doing the data cleaning. This is the one of the most important topic of data pre-processing. Let it be heading. Okay, center. Okay, so data cleaning, this is a very important process. So data cleaning is the process of detecting, correcting means maybe sometimes removing the corrupt or inaccurate record from a data set, record set, or the table, and also refer to identifying an incomplete, inaccurate, incorrect, irrelevant part of the data and replacing them. Okay, you can know. Thereafter we can replace, modify, delete. Okay, these are the process of a data cleaning. So basically we are cleaning the data by removing the incorrect, incomplete, inaccurate, irrelevant part of the data. So before this, let's first check is there is any null value in our data. Okay, let's is null. Okay, so let's see how many null values is in here. Okay, so you can see here the passenger ID have 0 null value, survive has also 0, but we can see the age column have around 177 missing values, means the null values. Okay, and the cabin has 687, but its size is 891, which means almost there's a lot of missing data. So we can easily remove this column cabin. Yeah, it's like 687 of the data are missing here. So we'll remove this and see the age. Actually age is the most is one of the, yeah, it's like how many percent, maybe around 800, 170, maybe around 20% of the age data are missing. They maybe the data of a labor or someone are missing. So let's visualize. Actually first let's visualize the same thing. Okay, so we'll be visualizing. Okay, let's visualize by the heat map. We'll be using the Seaborn heat map. Okay, we are checking it is null. We can take the white tick labels equals to false. Okay, let's check this. Okay, SD is not defined where I have written. Okay, df, I think there is a problem with my keyboard. Okay, you can see. So the age column have likely to have less number of missing data, but the cabin has a lot of cabin data, so we can, okay, let's give it more color to look it more beautiful. C map set. I think there is a problem to my computer. Okay, it's saying a error that we don't offset. I am telling the C map. I'm just like cam. Okay, this is a C map. Okay, let's see. Now check. I think this will look a little bit more beautiful. Okay, so we can see the age number have age and the cabin have more number of missing values. Actually, the cabin have the most number of missing values. So let's remove this column. Don't need this. df dot drop. Okay, we need to write a name. This is called the cabin cabin. Okay, axis equals to 1, and by placing implac, okay, by placing we are writing it as true. So we have successfully dropped the cabin column. So let's check once. df dot head set. So I don't see anywhere there is a cabin column. Okay, so we have successfully removed the cabin column. Okay, so we can see here even in the embarked in embarked we can check the embarked. Where is embarked? Okay, in embarked there is no missing value. Instead of the missing value, they have written it as NaN. NaN means not in number values. Okay, means the values they sometimes when there is no data, so we simply put NaN in the while in the data collection process. Okay, so let's remove all the NaN values. Okay, so drop Na in. Okay, let it be true. So I think we have removed all the NaN values. Okay, let's check again. By the same map. Okay, let's check again by the heat map. Okay, you can see here, so there is no missing or NaN values in here, and then you can get df. Okay, so it's showing that there's the error. Okay, there's the error. Sorry, I was busy somewhere. Okay, now it's right. Okay, we can see. So there is not. Okay, we can see see there is no null over any n value. Okay, after this, okay. So we have done this. Let's check our data types. D types. Okay. Show passenger ID is integer, and so we don't have problem with integers. We don't have problem with float, but we have a problem with the objects. So name could be the objects. We don't have problem, but here you can see the objects sex. They have represent the sex as object data type. So, and there's one more, embarked. Even they have embarked as the object. So we need to transform and map it into the another form that we call it simply data wrangling. Okay, let me make it either. Okay. Okay, data wrangling. So data wrangling is basically, it's a process of transferring and mapping the data from one form into the another format with intent of making it more appropriate and valuable for variety of downstream purposes such as analytics. Okay, obviously we are doing the analytics and analyzing. So let's check this p class. Sorry, let's check this sex class first. Okay, so we'll be checking the sex class. If there is a okay. At first I have told you at the earlier I have told you and okay, let it be first sex. Okay, let's see how many unique value it have. PNI PE, right? Okay, this is right. Okay, so sex has male and female, we know, but check if there is something wrong in there. Okay, we need to check the impact because that's only the impact object. Df in BAR. Okay, it impact status P. Okay, right? Okay, the unique UNI. Okay, this unique function will only give us the unique values. So there is S, C and Q. So we need to encode these variables. So we can do it by the, so we can remove this dummy variables by the pandas library, or we can use the sklearn for level encoder. So we'll be using the level encoder. I prefer the level encoder from the sklearn because it's more appropriate and there is likely to have less number of codes. So we'll be using the from sklearn processing, that's right, pre okay, sklearn pre-processing import level encoder. Okay, level encoder cursor. Okay, we can simply copy this function name. Okay, no module called sklearn, Matplotlib set, my mistake, LEA from sklearn. I think this one give us an error. Okay, we have success. Okay, it's still running, but I know this will run. So let's get rid of this object type. So we need to convert it into the integer type or in float type. Okay, so you will be using the level encoder dot fit, so it will be transform transform okay. Fit underscore trans df of 6 dot values. Okay, it's right, and we need to save this value into this name only. Okay, after transforming, we are saving this into the same column name. Okay, here you could have used the iloc for selecting the column name. You can use the iloc or simply loc, but I'm using directly the column name. Okay, so okay, impact, yeah, what's this one? EMBARKED. Impact. Okay, paste. Okay, EMBARKED. Okay, so okay, so we have successfully data wrangled. So let's check for data df dot head. Okay, so you can see the impact column. Before this there used to be QC some, okay, yes, CQ, but now it has 2 3. Let's check its data type. df dot the types. Okay, see here, so impact is the integer, so impact is with the 32, and there is one more sex. Okay, even we have converted into the sex. Okay, so let's see the sex. It's like the 0, 1 is for the male and 0 is for the female. Okay, so we can check even the sorry, that you can add. Okay, so it has taken 0 1. Okay, copy. So we have mostly impact, and it's like 2 0 1 2. Okay, 0 is for the one town, 1 is for the one town another town, and 2 is for the another town. Okay, simply you can say 2 is for S, C is for 0, and 1 is for Q in the Queenstown. Okay, so we are seeing here the passenger ID. Actually passenger ID does not have no relation with the survival rate, and even the name. Okay, it doesn't matter whether your name is Harry or Peter. And there's one more, that's the ticket. We don't need ticket data to predict whether you survived or not. So simply I will drop these columns df dot hot dropper. Passenger ID, and here's the name. Okay, so by this command we will be removing the passenger ID, name, ticket. Okay, let's enter. Okay, so let's check again. Here.gad. Okay, so we have removed all those things. Now after this we will be doing, okay, after this you can see the age is like 2238 38 26. The fair price is 7.256, but the impact is 2022, sex is 101, passenger class is 321. So the data isn't matching. So for this we need to, so we will be using the feature scalings. Okay, scaling, markdown. Okay, let's do it. Okay, even for feature scaling we will be using the sklearn from sklearn.preproces. Okay, standard scalar is okay. Okay, we have transformed. Okay, now we need to transform this scalar because in the pre-processing, whatever the function we are using, we need to transform it. So let's transform. Okay, sit feet underscore transform. Okay, f. Okay, that's the form. Okay, we forget to add one variable. We need to transform on which object. So sorry, actually I haven't supplied the features vector so before this I need to go into the, okay, insert a syllable. Okay, we need def and I'm defining feature vector. Okay, so there is a lot of way for this, but I will be using my style. But there's a lot of way you can define a feature vector, but I will be using, okay, also x equal to df dot, so I will be dropping the survivor column survived survived axis equals to 1. Okay, and because this is the outcome we are so this is survived at the outcome. Okay, so except survived will be taking each and every column, except this we will be taking this everything. Okay, and in the while, so there must only be survived. Okay, So we have successfully done this. So see here, for a feature scaling, survive column has only 0 and 1, which are totally relevant, but the x include, okay, we can see this, the x, you won't believe it. Okay, if you see, look at this x, you need to do like 3 1 2 2 1 0 7 5 2. You can see by yourself. Okay, now here we are feature scaling. So x equal to sc, and that's here we must give the x. Okay, you can see the x. Okay, so we have successfully scaled. After scaling, we need to split our data into the training and testing set. So splitting the data into train and testing set. Okay, so we'll be using the scalon model underscore sale selection so we'll be defining one variable. So we will be splitting our x and y into x training set, x test set, y train set, and y test set. Okay, so we'll be, so I'm adding a variable x train, x test, y train underscore y. Y train, y test. Okay, so these are the variables 1 2 3 4, and we'll be using the function, obviously this function. Okay, so we are splitting, actually we are implementing the, which we need to take the variable x y. For x we are transforming into two variables, and for y we are transforming into the and so x comma y. Okay, we need to give the test size, test underscore, it's your choice how much you want to give your, what's the percentage you want to give. So I'm trying to give, so I'm giving here only 0.2, means 20% of our data into the test set, and 80% of our data into the training set. And after this we can randomize, random state relative to 0. Okay, so see here. Okay, so we have successfully splitted our data. So now we need to implement, okay, the logistic regression. Logistic regression. Okay, logistic regression are used for the classifying the object, maybe object or a number of values with a little bit of a threshold. Okay, and so the algorithm which I'm using today, maybe I will be using 3 algorithm or 4 algorithm for implementing the model, and I will be discussing this algorithm later. Okay, in our new video. Actually I'm making a video for the Python, from Python to data science. Its name is from Python to data science. So I will be using it, so I will be uploading this video very soon. Okay, so we have from a scale on, always from a scale on linear model for logistic regression. Okay, let it be logistic regression. We let LR equals to we are copying this, yeah, spins right. Okay, logistic regression. Okay, now this is LR, and we need to fit into our training and the test data. Actually we have created a model that's name is LR. We have created one model, we have LR. Okay, so we are fitting our model into the training and test. So underscore train. Okay, even we need to do a prediction for testing purpose. Okay, so for testing always I have get around 20% of the data, that is the Y test. So we need to do it into the X test, then we'll be comparing it with the Y test, because this prediction will be our prediction value and this is the Y underscore test are our actual value, and we will be seeing this value into our confusion matrix. Okay, so we have okay, that's okay. So we have successfully implemented our machine learning model. Okay, after getting this we need to go for the confusion matrix for checking if our data is overfitted or not. So it's like the confusion matrix. Okay, confusion matrix is a very important topic in AI, so I'll be giving you a brief introduction. Actually confusion matrix is a table that is often used to describe the performance of the classification model or a classifier on the set of the test data for which the true value are known. Okay, actually I have worked. Okay, see here, suppose these are our actual class. You can see here our actual class is white test is our actual class, whereas in our prediction, okay, the value which I have prediction, these are the X test. Okay, this is the positive negative. Okay, suppose if our if our model is predicting any value as a true, and even in our actual class, even in our actual value it's a true, so we call it as a true positive, means the value which we have classified is a true positive, means that is true. Okay, suppose if our actual value is the negative, but our classifier has predicted it as a positive, so we call it as a false positive. And same as in, if our predicted value has classified our true value as a false, so we call it a false negative. Suppose if our actual value is a negative and our machine has predicted our value as a negative, so we call it as a true negative. I will be teaching you, or I will make a video, a brief video, not brief, actually I will be making a detailed video in the Bayes theorem and ROC curve. Okay, then I will be telling you so much about the confusion matrix. Okay, so let's check. Okay, from sk learn.metri cs matrix impo import confusion matrix. Okay, so it's very easy. So we'll be using this confusion matrix name confusion underscore mat matrix, so underscore test predicts predictions prediction. Okay, see here I have told you So 73 of the values is like our classifier. Which classifier we are using? We are using logistic regression. So logistic regression classifier. So this model has classified 73 values as a positive, and even in the actual values it's a real. So it's the true positive value is 73. But see here, our actual value is the negative. So see, this is 9. So 9 is like a number of counts. So our class has, so our actual value is negative, but our class has predicted it as a positive, so we call it the false positive. See here, negative. So if there is a negative value, and if there is a negative value and our classes has okay, and our class has predicted as the positive, so we call it as a false positive. So that value is 18. So 18, there are 18 values which our model has predicted it as a negative, but in the actual values 18 are likely to, they are the positive value. So see here, the 43 is like our model has predicted 43 data as negative, and even in the actual, even 43 are the actual values, so we call it as a true negative. Okay, I think that's enough for the confusion matrix. Okay, so let's check the accuracy of our model from SK. Obviously we are using the sklearn libraries, matrices, import accuracy underscore SCORE score and accuracy underscore score to. So while testing, for testing we always need to give the white test and the prediction, predictions. Okay, so our model is around 81. Okay, can multiply this for a nice view into 100. Okay, so around 81%, 81.11%. so our model is 81.11% accurate. So its accuracy, so it's a good model, it's a nice model. Okay, 81%. So our we have created model with 81% of accuracy by logistic regression. So now I will be using another, maybe I will be using the random forest. Okay, so using random forest classifier. Should I use hyperspace? No, I'll be using hyperspace in the another video for more accuracy. It's too much lengthy video. Okay, okay, we need to import this class. So from sklearn, learn dot and ensemble means the instance learning. Import random forest classifier RDC. Actually, random forest classifier is used to search the best classifier. estimators. Okay, common estimators we need to use citrons, C-I-T-E-R-I-O-N, citrons. Okay, so we'll be using the concept of entropy. Okay, see shift enter. Okay, so for the citron will be in entropy, and obviously random state. We don't want to fix our values, so doing random underscore state equals to 0. You can use any values. Okay, so see, actually it's quite easy. This is a logistic regression. At first we are importing the random forest here, and we are from here we class random forest classifier. Okay, see here classifier. Okay, CLASSIC. Okay, that's fine. So it's the same. At first we need to okay, you can use any machine learning algorithms. At first the only difference is the name. See here, at first we are importing the random classifier, and here we are using the logistic regression. Then we are calling the random forest classifier. See here RDC, we are random forest classifier. Okay, it's after that it's like the same. Okay, so you can do it by yourself. Okay, so let's train our model. Okay, it's getting okay. Random forest classifier. Okay, that's wrong. CLASSI classic. Did we? Okay, what's the spelling? Citron, CRI, CR, okay, CRITER, citron equals to entropy random equals to 0. Okay, something. Okay, it's like end of the where I have done a mistake. Set up here. You can use simply. And what the hell wrong with this computer? Okay. Let's run this. Okay, what is citrons? Okay, if we get any error, then just click this. Okay, paste in. Okay, it's a little bit slow. I think I can solve this. What? Maybe I think. Okay. Maybe. Okay. Let's see here. Okay, what this means? Okay, so now obviously when you get any kind of error, you can search in the what is not working even here. So you can try the shift plus tab, then it will give you. Okay, that's giving us shift plus tab. Okay, its spelling is okay. Double C, we don't need this. shift plus tab, control plus V. Okay, this will run now. Okay, it run. Okay, so we need to do the same. So let's use our confusion matrix, control plus V. So 73% are true positive, 9 are the false positive, sorry, true negative, and 18% are the false negative, and 43 what's that called, 43 are called the true negatives. Okay, so let's find the accuracy matrix. So let's simply find the accuracy. Okay, we will be using, okay, we can copy the same code. Okay, scalar. Okay, one repetition. Okay, it's both are coming the same. So is there any error? Y underscore text. Is this the way we are? Okay, accuracy score, that's the accuracy score. Maybe we define the prediction. Okay, let's predict once. Okay, let's change this variable. Okay, let us do this. We just need to differentiate the model name. Okay, it should be RD. Okay, now it's working fine. RDC dot fit, and it should be RDC. Okay. So predict confusion matrix. Okay, and its accuracy is 79.722%. Okay, the same way if you want, then we can even implement more classification like this, just like KNN neighbors, Gaussian, naive Gauss. Okay, so I am leaving this tutorial up to here now, because we have got a very nice accuracy, that is around 81%. Okay, so thank you for watching my videos, and I hope you have loved this. So if you really love, then please subscribe the channel, and in case of any doubt in any way, then please comment, or you can mail me. Okay, thank you very much.